And welcome to section 1.4, the Pythagorean Theorem. What you'll learn: to use the Pythagorean Theorem, and pronounce it correctly, to find the length of the hypotenuse of a right triangle. New vocabulary for this section: legs, hypotenuse, Pythagorean Theorem. Let's take a look at the skills you'll need with this check. The skills you'll need. Number 1 is vocabulary review. What is the square root of a number? And numbers 2 through 5, estimate the value of each expression to the nearest integer. Why learn this? The Pythagorean theorem describes the special relationship among the sides of a right triangle. You can use the theorem to find the side lengths of right triangles in structures such as bridges. In a right triangle, the two shortest sides are legs. The longest side, which is opposite the right angle, is the hypotenuse. The Pythagorean theorem is an equation that shows the relationship between the legs and the hypotenuse. Key concept, and this is one of the most influential, important, well-recognized key concepts in all of mathematics. The Pythagorean theorem. It states, in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And you can see that here below. The leg lengths are labeled A, B, and C, and the Pythagorean theorem is written out in equation form at the left. A squared plus B squared, note A and B are both legs of that right triangle, equals C squared, where C is the hypotenuse. You can use the Pythagorean theorem to find the length of the hypotenuse of a right triangle if you know the lengths of the two legs. And example problem 1, finding the hypotenuse. Example 1 says, find the length of the hypotenuse of the triangle. And here at the right, we have a triangle with known leg lengths and an unknown hypotenuse length. So our leg lengths are 5 centimeters and 12 centimeters, and our hypotenuse is labeled C. Well, right away, we can plug the two values that we know into the Pythagorean theorem and solve for our unknown quantity. So let's begin. A squared plus B squared equals C squared. Now, we need to let one of our legs equal A and the other equal B, but since addition is commutative, meaning we can add in one direction or the other and still get the same result, it doesn't matter which is which. So I'm going to let 5 be A, so 5 squared plus 12 squared equals C squared. Right, C is our unknown value, and for now it can just be the variable C. I could have chosen H for hypotenuse or X as a common unknown variable, but let's just leave it as C. That's how it's built into the Pythagorean theorem, and that works just fine. Now, note also that I'm not using the units, centimeters, in my equations. And often when we do arithmetic or algebra, it's nice to leave the units out of the equations. They just kind of clutter things up and aren't really necessary. We do, however, need to make sure that in our final answer, we reintroduce units to be precise. So moving on, 5 squared, well, of course, 5 times 5 is 25, plus 12 squared. At this point, you should have 12 squared memorized, or at the very least on your list of perfect squares on your notes list. 12 times 12, 144, equals C squared. And now, adding 25 plus 144, if necessary, use scratch paper. 144 plus 25, well, the 5 and the 4 is going to be 9, the 2 and the 4 is 6, and 100. So 169 equals C squared. You should recognize 169 as being a perfect square. That should also be on your list of perfect squares. Therefore, when it comes time to apply the inverse operation of squaring, which is our very next step, to both sides, you can begin to see already that that answer is going to work out nicely for us. I'm going to move this equal sign a bit to leave more room for the inverse operation of square root. And in algebra, what we do to one side of the equation, we must also do to the other to maintain the balance of the equation, the truth of the equation. So the square root of c squared, well, square root and squared cancel one another out. And moving on, we'll have just c all by itself. Remember, that's often our goal in algebra, is to solve for a variable or get it by itself. Isolate it, another way to say that. And the square root of 169. Well, 13 and negative 13, which can be written plus or minus 13 to represent both 13 and negative 13. Those are the square roots of 169. However, only one of those two square roots makes sense in this problem. Only the positive square root will be used to represent a distance or the length of side C. So 13, sometimes that's called the principal square root. We know there are two, but often we only need to use the principal square root or the positive square root. So C equals 13 in our algebra equation, but don't forget we need to introduce units, and we were asked to find the length of the hypotenuse of the triangle. So we could say, and it's already stated here nicely in the problem, so I won't rewrite the sentence, the length of the hypotenuse is 13 centimeters. And don't forget, including units is very important. These aren't 13 miles or 13 kilometers or 13 teddy bears, 13 centimeters.